Hello guys, so welcome back to my channel. Thank you for always stopping by. In today's video we're going to be looking at the concept of array, string and pointers, and so today we are just going to be doing an introduction in this video, explaining the whole concept of array, string and pointers to us and how we can basically understand this concept. And in the next video we'll be looking at the tags proper, so please follow, pay attention and learn. Very important. Okay, so now we look at arrays, okay, in C programming. And what are arrays? Arrays are actually data structure that allow you to store a collection of elements of the same data type. All right, so they allow you to store a collection of elements of the same data type under a single name. What do I mean by that? For instance, normally when you want to declare a variable, you say int a. So you can say int a, and you can say int a maybe equals to 5 here. Okay, and you declare another one, int b, and you say equals to 6, right? int c equals to 10, and so on and so forth. Yeah, now imagine that you have like 20 characters you need to declare. So you just keep, or 20 integers you need to declare. You just keep declaring this. All right. So in array, what an array does for you is that it helps you to declare a collection of data or type of, yeah, a collection of variables that have the same data type. All right, a collection of variables that have the same data type under a single name. How do I mean by that? You know how to declare an array when you say, so for instance, let's say this array is array of integer. So integer, so we can say array and then we'll give it a name. Let's say we'll give it a name and say the name is num. Yeah, so we can then say this is our array, and then we'll say array of 5, right? Something like this. So here we've been able to declare an integer array, and then we give it a name called num with a size of 5, meaning this array is 5. What does that mean? So this is a declaration of array, and then when we initialize this, meaning that we're going to have only 5 items because we have said that the size of this array is 5. What if we want to declare an array that will have a size of 20? That means here we're going to have 20 here, not 5. All right, so this is going to be 20. So we've declared an array of integer with the name num, and then the size is going to be 20. That means we can have 20 different characters here. All right, so we can initialize it by saying, okay, so this, so each character or each integer, we separate it with a comma. All right, so you can have positive numbers, you can have negative numbers and all that. So you can initialize it like this, saying, okay, I have array, and the array is size of 20, and you can put in up to 20 integers here, all right, inside curly braces. So this is how you can declare an array in C programming, and this is also how you can initialize array in C programming. Now let's step it down a bit. I want to take this very simple and try the best I can to break down this concept in such a way that we will understand this properly. All right, now let's take this again. We're going to declare an array, and let's say this array is going to be of size 5. So int, and let's call it num again, int num. All right, square bracket, size of 5. So here we have declared, so this is semicolon, we have declared our array, right? Now, so this is array declaration. All right, so how do we then initialize this array? So let's see the initialization of this array. Let's see how we can initialize this array. So here we say int the name, which is num, and then the size inside square brackets. Of course, the size is 5 here. and we say this is equal to, we open our curly braces and give it a size of 5. So we can say 0, 10, 5, 3, and -2, right? And a semicolon. So here we've been able to declare our array and initialize our array. So this is how you can initialize your array. All right, so we say this array is a size of 5, and because it's a size of 5, we have to put 5 items inside our initialization, that is inside the curly braces. So we have 1, 2, 3, 4, and 5. So that is how you can initialize your array. Okay, so you declare your array and then you can also initialize your array. So you cannot do this int num 5 and then you initialize by saying equals to c, 1, 2, h. All right, you cannot do this because from the definition we gave, it must be of the same data type. C is a character, h is a character, 2 is an integer, and 1 is integer. So for you to be able to work with array, you must always declare the same data type, and then you can knit those data types together. All right, so if you're going to make a declaration for integer, everything should be integer. Initialization should be integer. It should consist only of integers. If you are declaring for character, which is for char, it should be of type character. All right, now let's do this. If you are declaring for a character, let's say we have character, and then let's give it a name by saying, let's call it name. All right, let's call it name. Here, for you to be able to hold this, you will use the single quote for character. So we can say something like x, all right, inside quote. The next one, u, will be inside quote, comma. The next one, n, will be inside single quote, comma. The next one, d, will be inside single quote, comma. The next one, a, will be inside single quote, comma. And the next one, y, will be inside single quote. So for character, you must put them inside quote. You remember that whenever you're dealing with characters in C, they have to be inside quote. But if you're dealing with integers, all you need to do is just to put the commas in between. So this is how you can initialize character in C programming. But if they are integers, there's no need for the single quotes. All you need to do is put your integer 1, 2, 3, 4, and so on and so forth. All right, so that is how you can declare your characters. Remember that you cannot put items of two different data types in one array. If it's character, it has to be character. If it's integers, it has to be integer. If it's float, it has to be float. If it's a string, then it has to be a string. All right, now let's move on a bit. Please try to understand this concept. These are things that are going to help you, and you're going to see them as you begin to work with arrays and pointers. Okay, now let's step it down a bit. Now in arrays, we have what we call memory allocation in arrays, and we have what we call address in arrays. Okay, so by the time you declare an array, for instance, let's do this. Let's declare this and say this is, let's use integer again, and let's say this is int a. All right, and let's say size of 3, and let's just give it 1, 2, and 4. Okay, so here we have 4. Now let's say we have we are dealing with this, and let's all right, so now we have declared this and we have initialized this. In array, the address of that array is always denoted by the first number of that array. So this is what I mean. Let's say we have this, all right, and the name of this array is A. So this is the memory that is allocated to this array, all right, in our computer. Let's say this is the name is A, and this array is array of 3 items. Now in array, if you want to access an array, you start from 0, 1, 2, 3, 4, you know, and so on. Okay, now if we are to access this array, this is an array of 3 sides. If we are to access this array, for us to be able to access this array, which is this item 1 here in our array, we are going to use the index number of 1, and the index number of 1 here is 0. The index number of 2 is 1, and the index number of 4 is 2. So in our computer, the memory allocation place for our array of A of 1 is going to be 0. So the index is 0, and here is 1. Now there's something called the address, all right, because it's the address that you use to locate where your array is stored in your computer. So let's just give this a random address and say the address is 100. The next array, the index of the next array, which is 2 of A, is 1, right? For us to be able to access this is 1. So here we'll write 2. And let's say this is 104. Why is it 104? Because this is integer, and integer in our system has 4 bytes. It's allocated with 4 bytes. So that means it's going to take 100, 101, 102, 103 for us to be able to store this one. It takes 4 bytes. The next one will also take 4 bytes. That means here, where we have our index of 2 and the value is 4, our address is going to be 108 because it's 4 bytes for integer. For character in 64-bit system, 64-bit, my computer is 64-bit. If you are using a different system, it's going to be a different maybe 2-bit. All right, it's either 2-bit or 4-bit. But for 64-bit system, it's always 4 bit it's going to carry. Now for character is 1 byte, for float is 4 bytes. All right, let's just see the size of all the size of float. I think we did this before, but we're still going to look at that and see how this memory is allocated. So here we have, for us to be able to access 1, we need the index 0 to be able to access 1. And in C programming, the address of this array is 100. It always gives the first address of the array to the to this specific array. So if you are going to access this array, then you will access it with 100. By the time you get the address of this address, you'll be able to access the whole of this array. Yeah, I don't know if that is clear. The first address is always assigned to the array. So by the time you access this address, you'll be able to access the whole of this array. I will explain this in detail, no problem. Just follow me carefully. All right, now like I've said, for you to access a particular array, you have to look for the index number, and remember that the index number in array starts from 0, 0, 1, 2, 3. So if you have an array of size 3, the index number is going to end in 2 because the array is going to start, the index is going to start counting from 0, 1, and 2. Cool. Now let's do something. Let's go to our terminal and do something. Here let's just create a file, call it array. Okay, and here let's just as standard. io.h, and let's call on our function. Okay, so let's declare an array. Let's declare an array and say an array of int a. Let's just use what we have there and say 3, right? Say 3. So now let's just see, let's printf, let's see the size of array in a computer. So we say, size of integer, %d, right? Let's give it a new line. So size of course you should know how to do this already. We created this some time back. All right, so let's also just do this for float, for character, so that for 64 bits, so that you see the size, and then you know, so that you also know how much memory is allocated to sorry, this is an unsigned int, so unsigned long, so it's supposed to be lu, not %d. Yeah, it's lu, it's unsigned long. So here, new line, and size of, so character, and then let's do for float, so size of float, sorry, that's supposed to be, I'll correct that, that's supposed to be character, not integer again. Size of, so let's pass in float here. Yeah, okay, let's correct this. All right, so let's run this and see. Let's run this and see. So gcc array.c, let's output this to, let's say, just a, so that it doesn't stress us. Fatal error, no file. Oh, there's a mistake in that spelling. Okay, so we've compiled that. So let's call on our file, hit enter. So you see, size of integer is 4, size of character is 1, and size of a float is 4. So for a 64-bit system, the memory allocation for an integer is 4. So that's why the address is spaced by 4 bytes. So 100, 105, and 108. All right, that's what I just wanted us to see. Okay, so let's move on. The next thing I want us to look at is initialization of array. Initialization of arrays. Okay, so we have two types of initialization. We have the compile time, and then we have the run time. Okay, so let's look at compile time initialization, which is what we've done before. All right, what we've been doing is compile time initialization, that is saying int, let's say int b, give it a size of 3 and equals to 1, 2, 4, right? So this is runtime initialization. Why is it runtime initialization? Because we are initializing it as we declare it. All right, but for runtime initialization, you run it after you have declared it. Okay, so we'll get to that. You run it after you have declared it. So for compile time initialization, this is how you can initialize your arrays. Okay, now by the time you initialize your array this way, it's most times for smaller arrays because you can initialize it this way. What if you have like a size of 100 you want to initialize? So that means you're going to do this, comma 5, comma 6, comma 7, comma 8, comma 9, all the way to 100. So this is why we also have the runtime initialization, where you can basically declare and then you run it using loops. Okay, you run it using loops. So we're going to look at that pretty soon. All right, so let's go ahead and look at runtime initialization. So the second one is runtime initialization. Now, how do we initialize in runtime? Let's declare this and say int I for looping purpose, and then we say int, let's call this int C or int A, whatever. Okay, and then let's give it a size. Let's just say a size of 5 for now. Okay, so here we declared I because we want to use I for loop. You can also say something like int C and then give it a data type, a size, and you say comma I and this. So this is the same thing as this. So in C, give it a size, comma I is the same thing, because this is an integer, this is an integer, so it's okay. But you can also declare it this way, which I always love to declare this way for simplicity purpose. All right, so now we've declared our I, we've declared our array. The next thing we need to do is, for instance, let's say we want a user to impute an array for us, right? We want a user to impute, so we don't know what the user is going to impute. So how do we do this? We can use printf to just add the user for input and just say enter, maybe enter the element of an array or enter 5 numbers or whatever. So let's just say enter 5 arrays, right? Or 5 numbers, enter 5 numbers, something like this. And then we can use, remember, we can use our loop now, our loop. So let's use a for loop. I'm sure you are conversant with loop now. For I is equals to 0, right? And we say I is less than, so this is 5, so let's say I is less than 5 here, because the index starts from 0. All right, so I is equals to 0, I is less than 5. If I is less than or equals to 5, that means it's going to be 6. So we say I is less than 5, and then we say I plus plus, yeah, for loop. Okay, now we can then ask for input from our users and just say, use the scanf function and ask them to impute. So we say scanf, and then we'll ask them to impute. All right, so this is %d, and then ask them to impute something. So here we're going to use a address of C, and then what, I. Okay, so here we're asking our users to impute something. Let's do this in proper program so that we'll see how this looks like. So let's just okay, so here we are just going to remove this. So let's say int A, right? Int A, and let's also declare int I for loop. Okay, so we have declared these two. So here let's printf and ask the user for input and just say enter the elements of this array. Okay, and then let's use scanf to accept it after the for loop, and we say for I is equals to 0, and I is less than 5, right? I is less than 5, I plus plus. Okay, so I plus plus. So here we can say plus plus, yeah, no semicolon there. Okay, so here we can say scanf. Let me just use this. Scanf, we can say, let's just ask for the user to impute something here. So the user will just impute random numbers, sorry, %d, and then let's call on the name of our array, which is in this case A. So address of A ampersand A, right? Okay, so this will allow our user to impute the elements of this array, right? So let's give this array a size of 5 because we are saying 5. So let's give it a size of 5. Okay, so here we can then use another for loop to print out the input. So for I, same thing. For I is equals to 0 and I is less than 5, I plus plus. Okay, and here we're just going to say printf. So we're going to say printf. Now we need to print whatever the input was. Okay, whatever the input from the scanf was. Remember, there was a scanf for input. So whatever the input was for scanf is what we're going to print out now. So %d, let me add a new line character here. So address of A and okay, so let me also add a new line character here. Let me also add a new line character here. All right, so here we are saying enter the element of the array, and the array size is 5. All right, and then we use our loop for this, and then the scanf to accept the input of our user. Let's do away with this so that we see how this works. Okay, so now let's go ahead and compile this and see. Okay, let me see what this error is all about. Okay, so let's look at our file. What are we supposed to do? Okay, so here we're not supposed to put this address. Yep. So this is just A, not address of A. Yeah. And then let's add a return statement. Let's add a return statement and see. So let's run our code again and see if this will work. Okay, it has. So let's see. So enter the element of this array. So let's say 20. So we're entering 5 elements, 52, 7, minus 1, minus 4, 2, and 50. Alright, so it's printed it back to us. Okay, but it's not very visible. Let's do something so that we will see this properly. Let's add a printf here. Let's add a printf here and just say printf. Let's say printf the element of this array, let's add a new line character. Okay, so let's compile again and let's run our code. Enter. So we're going to enter 5 numbers minus 5. Enter 50, 89, enter 5, enter. Okay, so you see now, so the elements of this array are, so we have 20, we have minus 5, we have 50, we have 89, and we have 5. All right, so here you can impute the number yourself, the number of array or whatever item you want to put in your array yourself, and this is for runtime initialization. So like I say, runtime initialization is like the best initialization you can have for your arrays. Even if you don't want to accept input, let's say you just want to run the array by yourself, you don't want to accept input, you can also use runtime, and you are able to with if statement, rather than using the loops now, with if statement you are able to get your arrays printed for you. Okay, let's move on. The next thing I want us to talk about is memory allocation in C, which we've touched briefly already. I just want us to go through that again, and then from there we will jump into how to access memory in C. Okay, now we have this memory allocation, we have this memory representation. Sorry, let's start with memory representation. So we have, let's say we have int a again with a size of 5. So this is the name, this is the data type, and this is the size, the name of array, the data type, and this is the size. And let's initialize this and say 1, 0, 2, 12, 10, 1, 2, 3, 4, and 5, right? All right, so this is our array. Now, like I say, for integer on a 64-bit computer is 4. So that means the total size of this array is going to be 4 times what? 4 times 5, which is equal to 20 bytes. So that means the total size that will be allocated to this array in our computer is going to be 20 bytes, right? So so the total size that will be allocated to this computer, to this our array, is going to be 20 bytes. So from here to here, we're going to have 20 bytes for this, because each of these represents 4. All right, because they are integers, it represents 4. So the total that will be assigned to it is going to be 20 bytes. How do I mean? So this is going to be 1, this is going to be 0, this is going to be 12, this is going to be 10, and this is going to be 5. And each of these is represented by 4 bytes each, and then like I say, the memory address. So this can be 100, 104, 108, 112, and 116. All right, because there are 4 bytes separating each of them. Okay, now let's move on a bit. Now let's look at how to access the address of the elements. Okay, address of the elements. Now we have this, and then we have, let's say the first address is 100. So let's denote that by saying this is 100, right? The first address is 100. So we say 1. So let's say 1 is 100, right? 0, 12, 10, and 5. Okay, 10 and 5. How do we access the address of any element in an array? There's a formula you can use, and the formula you can use is A, which is the name of the array, plus 3 times A. Now this name of the array is actually taking the address of the array. All right, taking the address of the array. So address of the array, which is the first letter of the array, or the first number of the array. So this is going to be 3 times this. For instance, 3 times 4. What does this mean? That means the third element, which is 0, 1, 2. So this is, now let me do this so that we understand. Okay, so please just pay attention so that you will understand. Let's say we want to access the memory allocation for the first element. The first, let's say the second element, right? The second element is 0. The index of the second element is 1, right? Because this is the index 0, 1, 2, 3, and 4. So we say the address of the first array, which is the name of the array, we denote that by A, because of course we get to pointer so you understand what it means by this, because the first item of the array owes the address of the entire array. We'll get to that so you understand. But let's say you want to pick each of this number, all right, because remember that this is 20 bytes because it's 5, and 5 times 4 is 20 bytes. So we'll have 20 bytes here, right? So that means these all items in this array, they have 20 bytes, 4, 4, 4, 4, 4 allocated to each. But now we already know that this A automatically picks the address of all of them. But we want to access each of these. Each of these has 4 bytes inside. 4 bytes inside. We want to access it. So how do we get it? The formula is the address of the first element, which is address of A, plus the index of the element we want to access. So let's say we want to access the second element, which is 0. So the index is 1 times the size of the data type, which is 4 for integer on 64-bit system. So this is going to be 1 times 4 is 4 plus 100. So 1 times 4 is 4 plus 100, which is equals to 104. So for this, the next item, which is 0, is going to be 104, right? So let's go to the next one. Address of A plus the index of this of 12 is 2. 2 times 4, which is the size of the data type of integer on 64-bit system. 2 times 4 is equals to 8. 8 plus address of A, which is 100, is equals to 108. So here we'll have 108. All right. So in a nutshell, you can use this formula for you to be able to access any the address of any element. So like I say, each of this is 4 bytes. So from here you can see. Now let's want to calculate for the first element, which is A, is simple. You say address of A, which is 100, plus the index of 1 is 0. So this will be 0 times 4. all right, which is the data type of integer. 0 times 4 is 0, so this will be 100 plus 0 is equals to 100, so we'll have 100 here. So you can, that is how you can get the address at any point in time of any element in your array. I hope this is clear enough. Okay, let's move on. Finally, before we move to pointers and string, which I'm just going to explain them briefly because we're going to see more of them later, but I just want us to understand the concept of this array. How do you access an array? How do you access an array in your system? Let's go back to our computer and let's try to write some codes here. Okay, so let's do this now. Okay, so this is a standard. So let's say we want to access an array. Let's declare an array here and give it a name. Let's just call this A again and give it a size of 5, or let's give it a size of 3. Okay, and then let's initialize this array and just give it numbers. I'll just say 4, 0, 2, 5. Sorry, size of 3, so that's 3 numbers. Yep. Okay, so we've declared our array. Yeah, we've declared our array. Now let's try to access our array. Please pay attention. Let's try to access our array. We are going to say %d, of course it's integer, so %d, let's bring it in a new line character. Now we want to access our array using the index. If we are to access 4, which is the first item of our array here, we will use 0 here, because the index of 4 is array or 0. Like we say, you start from 0, 1, 2. So if we want to access this, so if we say A now and we pass in 0 here, right? We pass in 0 here, what we are going to get is whatever it's in 0, which is 4, is what we are going to get. So let's go ahead and print this and see. So let's run this and see. So you see what is printed is 4. Why is it 4? Because the index 0 is holding the item 4. So that means if we say index 1 now, index 1, that means it's going to print 0 for us because index 1 is 0. So this is 0, 1, 2, 3. So let's go ahead and print this. So it printed 0 for us. All right, so that is how you can access your array using the index number. Very, very important, guys. Please pay attention. Now, how do you now access the address of an element in array? How do you now access the address? Now here we are just printing the array. Let's see how we can print the address. So printf, we're going to say printf, and let's pass in our %d, %p for address, sorry, %p for address, and then here we'll pass in the ampersand, and then we call on the name of our array, and then let's say we want to print the address for index 1 also, right? Let's print the address for index 1. All right, so here we want to print the address. So here we have the index, we have the value, we have the address in array, remember? So let's run our code and see if it will compile. It has. So let's run our this thing. So now you see the address for index 1 is 40. Now let's do something, guys. Just follow me. Let's do something. Here, I want us to see something. In C programming, your arrays are always given memory allocation in this format. In this format. All right. If the first address of this array int a 4, if the first address of this array is 100, right? If it's 100, the next address is going to be 104. The next address is going to be 108. The next address is going to be 112. That is if it's integer. If it's character, if this is 100, the first is 100, right? Let's call this B. If this is 100, the next address is going to be 101. The next address is going to be 102 because it's 1 byte each, 103. All right. So this is how memory is allocated in a continuous form. You cannot have same array. This is 100 and the next one is 100 and maybe 204 or 314. No, it must always follow suit. So if memory is going to be allocated to your array is in continuous form this way. So 100, 104, 108, 112. Let's see something. If we're going to print f now. All right, let me just copy this. Copy. So we're going to print f now and try to okay, 1 2 3. Okay, so let me change this to 0. So let's print from 0. We can also use loops to do this, but I don't want us to start writing. Oh, that's actually 1 already. So okay, so let's print this address of 0 and let's try to copy this also. Let's copy this. So here, address of 1. Here, address of 2, right? So let's compile and see. So we are basically going to print the items in our array and then we're going to print their address. Now look at this. Now you know this is in hexagonal form, so 6C is in hexagonal. All right, but look at this. After the 6C, you see this is 70, you see this is 74. If we have, let's increase this to array of 5. Let's increase this to array of 5 and say 5. All right. Free. Okay, so let's see. Now what is going to happen is that it's going to give us a different location but in a continuous form. Let's do this and let's compile and then let's run our code. See, now you see that we have 90, 94, 98, 9C and this. So this, of course, like I said, this is a hexagonal form. All right, so you see that it's in continuous form. So it's going to give you an array in continuous, or address in continuous form. It will not give you 94 and then, or 90, and it gives you 84, 12, or whatever. It's going to be continuous, right? So that is how you can access the address of your arrays in C programming. Okay, now I think we've come to the end of of arrays. I've been able to show you guys how you can work with arrays. The next thing we will look at briefly is strings. Let's look at strings, and then the final thing we'll be looking at will be pointers. So let's look at strings first. Strings in C programming. Strings in C programming. So let's look at strings. I'll clear this. And so strings, vi strings.c. okay, hash include stdio.h. okay, so let's call on our main function. Let's bring it down. Okay, so now strings in array, same thing. The difference is that here we're using character, okay, and then we pass in our string, our size, okay, we pass in our size, and let's say we want to print let's print something and just say maybe Sunday, right? Okay, so here if we say printf %s, of course it's a string, so it's %s, and then we'll pass the name. Okay, let's give it a name. We didn't give it a name, so let's give it a name and say the name is name, right? And then we call on name. Okay, so let's go ahead, gcc string.c, let's output it to a. Okay, now if we run our code, you see it's printing Sunday for us. So that is how you can declare your string in C programming. That's how you can declare your string in C programming and print it out. Now let's go back again to our file and see something. Here you see that we have character name, all right, and then is a string. But what if it's character? How do we do this? If it's a character, then instead of using the double quote, we're going to use single quote and say x, okay, and here we say x, comma, then u, comma, n, d, a, y. Okay, so you see here we use single quote, but for string you use double quote. Now how do you now get this? Of course it's a character, so instead of x is c, remember the format specifier, and here, yeah, so it's name, and then we're going to pass in, let's say we want to pick the n. N here is going to be what's going to be the number 0, 1, 2. So we'll pass in 2. All right, we'll pass in 2. That means 2 is supposed to give us n, right? So enter, you see it's n, okay, because we are using the index to pick that. So that is for character in strings. So if you want to pick character, you use C as your format specifier, and then all your arrays will be in between single quotes. And if you want to use a string, which is a combination of numbers, you use double quotes and then with %x, that format specifier for string. Okay, now let's move to pointers in C programming. Now the same way, you can also try to get the address of this. All right, I try to repeat these things so that you can also pick them. Address of this, remember this is %p because it's the address you're looking for. All right, and here you can just pass the address of so address of A, right? And then you can get that. Please, I just want you guys to really get this. It is important that you do, so that you will not have issues with your so I'm not going to save this. I will just with your task. Okay, now let's go to pointers in C programming. Let's go to pointers in C programming. So we look at array, we look at string, and now we're looking at pointers. stdio.h, and let's bring in a main function, int main. Okay, pointers in C programming. Now, pointers actually just like saying they point to a particular address. So when I was trying to explain address, I told you we're going to revisit this. They point you to a particular address in your array. Okay, they point you to. Okay, so let's look at this. So like I say, pointers point you to the address of a particular variable. So in C programming, pointers are variables that store memory addresses. Okay, so there are powerful features in C that allow you to manipulate memory directly and efficiently. So let me explain what that means with example. Let's say we have this. Okay, let's say we have int A, or let's say int number. Okay, let's have int number, and let's we have int P. So let's denote this. So this is a pointer, so let's just use P to say this is a pointer. And let's say that number, let's say number is equals to, let's give it a value 20. Okay, let's give it a value and say 20. And then let's say let's say P is equal to address of number. Okay, or not to confuse us, instead of this, we can just declare and initialize one time and say this is equals to, let's say 40, right? Okay, so now we've declared our number, we've declared the pointer, and then we say that the pointer now is equals to the address of number. So whatever is the address of number is what the pointer is, because it points directly to the address, and you can manipulate your data and your value with your pointer, which is very powerful in C programming. Okay, so let's say now let's just print out. So I'm going to say printf, sorry, before then let's give a space, printf, and I will say value of number. Yeah, so let's print the value of number. Value of number, that's %d, give it a new line character. Okay, and the value of number is %d, right? So the value of number, and then let's pass the name, which is number. Okay, now let's do the same thing, printf, and now let's print the address of number. Address of number. So we say address of number, right? Let's pass the %p for address, and then here let's pick number. Okay, now using the pointer, now we are going to use the pointer now to pick the value of number. Again, value of number. So now we are picking the value of number, but invariably what we're saying is I want to print wherever number is, we want to print that address, and we can manipulate it with, we can manipulate that with the pointer, right? We can manipulate number or the value of number with the pointer, and I'm going to show you what I mean by that. So this is going to be %d. Let's also have a new line character, %d, and then let's pass our distance, our pointer, which is p. Okay, and let's just have a return statement. Okay, let's run this and see, or let's compile first and see. So we're dealing with pointers right now, so gcc pointers. So let's output this to t, right? Okay, there's a challenge warning format with inbox. Okay, let me see. Int. Okay, let's see that. Where is that error from? Okay, I've seen it. So this is a pointer. Okay, so let's do this again. Whoa, what's happening? What is happening? Let's see what's going on here. Oh, my bad. Okay, this should be good now. Let's clear our screen. Yep. So let's go ahead and run our code and see t. Okay, now guys, so this is it. Let me cut our file. Now. Pay attention. Now you see that here we printed the value of number is 40, right? The value of number is 40. Of course, the value of number is 40. The address of number, of course, he printed the address of number for us. You know how to print the address of number, which is with %d. The value of number again, you see here we said the value of number again using the pointer, which points to the address of number, is printing for us 40. Points to the address of number. So instead of printing the address of the number, it's printing the value of the number. Why? Because this pointer points to the address and it holds the value of the address, meaning that wherever the number is, this pointer holds that. So that means we can manipulate this with, we can manipulate the number with the address. Now let's veer into our file and let's do something. I want us to do something. So here, let's declare something like this. I hope this will work, but it should work. Let's just declare something like this and say p, and here let's say p is equals 20 here, right? Let's say p is equals 20, and let's copy this. and paste here. Okay, so this should work. Yep, it has. So now can you see, let me cut this again. Can you see here we have 20, the value of number is 40, right? The address of number is this, the value of number using the pointer is 40, and now we decided to say, okay, let's manipulate this number, and we change the address, we change number using the address, which is a pointer, from 40 to 20, and we ask for the value of number again. Here we ask for the value of number, it was 40. Here we ask for the value of number, now we have 20. Why? Because we've been able to use this pointer, this P, which is pointing to the address of 40, to manipulate this number. So this is how you can use your pointer to manipulate your arrays. Like I say, pointer is very important and very powerful. We're going to need this all over as we go on. All right, so this will bring us to the end of this video on array, strings, and pointers. If you love this video, just leave us a comment and do well to share. The next video is going to be on the task, array, pointers, and strings. So see you in our next video. Bye for now.